Hello and welcome to another video in this series. Today we are going to discuss about the ultrasonic sensor and we are going to interface this sensor with the Arduino board. So let's get started. Ultrasonic sensor is a sensor that actually measures the distance. The sensor works by emitting a sound wave of around 40 kilohertz, and this sound wave travels through the air at the speed of sound, and if there is any obstacle in between, then the sound wave will reflect back from that obstacle, and the time taken for the sensor to receive the bounced signal is actually used to find the distance between the sensor and the object. So this is what the sensor looks like. It has got 4 pin VCC, trig, which is also called a trigger pin, and echo pin, a ground pin. So this here is a transmitting sensor, and when the sound wave transmitted from here reflect back, then the receiver here will receive that reflected signal. So VCC here actually connects to plus 5 volts in Arduino. Trig is a trigger pin that is an input to the sensor, which means it has to be set up as an output pin from the Arduino. Echo is an output of the sensor, which means it has to be input to the Arduino. And then there is a ground pin that connects to the Arduino ground. Now let's look at the operation of the ultrasonic sensor. First, transmitter actually sends the sound wave, and when the sound wave hits the obstacle, it will get reflected back to the sensor. Then receiver here receives the reflected wave. So the distance between the sensor and the obstacle is calculated by calculating the time from the sensor to send the wave and receiving the reflected wave. So let's look at the timing diagram of how the sensor actually works. So at first, the trigger pin or the trig pin will have a 10 microsecond pulse, right? So this signal is high or logic 1 for 10 microsecond, and then it goes to low. So when the sensor receives this kind of signal in the trigger pin, so it rejects the 880 kilohertz sound wave pulse from the transmitter. And the receiver in the ultrasonic sensor will listen to the reflected wave. And the echo pin will calculate the time taken by the pulse to leave the sensor and return back, right? So whenever it receives the return back signal, it goes to low. So this time here, the time the sensor sends the sound wave and the time when sensor receives the sound wave is actually the time of travel between the source and the obstacle, right? In our case, the time between the sensor and the obstacle. So this time is actually used to find out the distance. So now let's see the analysis here. So let's assume that this is a sensor here. So it is transmitting a wave. We have an obstacle here. So this wave eventually hits the obstacle and then this wave reflects back to the sensor. So this is how the sensor calculates, right? So we know that the velocity of the sound is 340 meter per second, right? Which is also equals to 0.034 centimeter per microsecond, right? Now, we also know that time taken is equals to distance divided by speed, right? Now, with this formula, we know that time taken can be obtained by the distance s divided by the speed v. So in our case, we need to find a distance, which is s, right? So this time here is obtained from the sensor with the help of echo pin. Now, once we have the time, we can use this formula to obtain the distance, right? Where distance is simply equals to time multiplied by the velocity. Now, in our case, we are using a velocity in centimeter per microsecond. Just to make our calculation simple, we are converting 340 meter per second into 0.034 centimeter per microsecond. And this value is divided by 2 because our wave actually travels from sensor to obstacle and from obstacle back to sensor, right? So it travels twice the distance. So to fix that, it is divided by 2. Now let's look at some of the function that we will use to run this distance sensor. First is pulse in, right? So pulse in actually reads the pulse from any digital pin, either high or low. And if the value is high, then it waits for the pin to go from low to high, and then it starts counting, it starts the timing. Then it waits for the pin again to go low, and then stops timing. So it actually counts the time when signal is high to the time when signal is low, right? So this is exactly the function that we need in order to find the time that wave takes from the sensor to go to the obstacle and come back to the sensor, right? So this will help us to find the time. So this will actually returns the value of the pulse in microsecond. For example, pulse 10 comma high will actually look for the high pulse in pin number 10, right? And then it goes from low to high, it starts timing, right? And waits for the pin to go to low again and stops the timing, right? Now, another function that we'll use is delay microseconds. So delay microseconds is exactly same as delay, but the only difference is that delay will wait for the microcontroller for time in millisecond. So delay microseconds will wait for the will pause the Arduino in microseconds, right? It is similar to delay. So the way to use it is also similar. Delay microseconds 10 will pause the Arduino for 10 microseconds. Now let's look at the code that will display the obstacle in centimeter, right? So the first thing that we have done here is declared a variable which is of kind float, right? Meaning it will store the decimal value. So these two variables are used to store duration, which is actually the time the sound wave leaves the sensor and return back to the sensor from the obstacle. And then there is another variable distance, which actually holds the final result in centimeter. So in the setup function, we are connecting trigger pin to digital pin 9, and this is the output pin, right? And then there is another pin, echo pin, which is connected to digital pin 10, and it is a input pin. So this line here is setting up the serial communication. Then inside the loop function, the first thing that we want to do is that we want to make sure that the trigger pin is low. If you look, this wave, we want to have the trigger pin low and then it goes to high for 10 microseconds, right? So to make sure that this trigger is low initially, we do this. Then we will set the trigger pin high for 10 microsecond and then finally set the trigger pin to low. So once this is done, the sensor will transmit the sound wave pulse, and the next line here, pulse in 10 comma high. So this is the function that will actually read the echo pin and calculate the time in microsecond. That will actually calculate this time, the time from this point to this point, which is actually the time taken by the pulse to leave the sensor, and this is the time when the sensor receives the returned signal or reflected signal, right? So once we find out the time in microsecond, all we need to do is that implement that formula that we discussed earlier, which is time multiplied by 0.0343 centimeter per microsecond divided by 2. And then once we have the value of distance, then we can send this information back to the computer or the serial monitor. Now let's write a code to blink the LED connected at digital pin 13 if the obstacle is less than 5 inch, right? So notice that this time this distance is in inch, so you have to convert the value that you have obtained here, which is in centimeters. Then use that value in order to blink the LED if it is less than 5 inch. So let's pause the video here and write the code. All right. So here, additional code that we need to write is this line here, right? To set up a pin, digital pin 13 for LED as an output pin, right? And then once we obtain the distance value in centimeter, we can use this formula, right? Distance is equals to distance divided by 2.54 to convert the value in centimeter to value in inches, right? So this function actually converts the value that we have obtained here, which is in centimeter, to the value in inch. Now, once we have the value in inch, we can use this value to to be used in an if-else block to blink the LED. So which can be done in this way, right? So this is IN, not IM. So once we have a distance in inch, we can use if-else statement, right? So if the distance value is less than 5 inch, then we can turn on the LED, wait for 100 millisecond, turn off the LED, wait for 100 millisecond, again turn on the LED, wait for 100 millisecond, turn off the LED, wait for 100 millisecond. So this code will actually simulate a blinking effect. And if the distance is not less than 5 inches, then we can actually turn off the LED and wait for 100 millisecond, and then again start everything from the beginning. Again, calculate the new distance if the obstacle has moved, right? So this is how you write the code. So now let's look at a demo of this code. So let's look at the setup here. This is a distance sensor here, and it has got a VCC connected, ground connected, trigger is connected to pin number 9 here, and echo is connected to pin number 10 here. So once this setup is done, we can see the code here to calculate the time in centimeters and send this value over the serial channel to the computer, right? Now let's transfer this code to the Arduino. Compiling sketch, compiling, done uploading, and then done uploading, right? So now let's open the serial monitors. By the way, this is a quick link to open the serial monitor. When you click here, serial monitor shows up. Let's clear the output, and we can see the distance right now is 17.46 centimeters. So now let me bring in the obstacle close to the sensor, and you can see as the obstacle moves close to the sensor, the distance is actually going down to 7 centimeters, 6 centimeters, 5, 4. So this code is actually showing the interface of the sensor, right? So now let's use this value and blink the LED if the distance is less than 5 inches. So let's look at this code here. So this code is adding an LED here at pin number 13. And then this line here is converting the distance in centimeter to distance in inch. And this piece of code here is for blinking the LED only when the distance is less than 5 inch, right? Else the value, else the LED is off, right? And then we wait for 100 millisecond, and then again repeat the same task of measuring the distance, converting it into inch, and then checking if the distance is less than 5 inch. If it is true, then blinking the LED, else turning off the LED. Now here everything is connected as it is. The only thing that is extra in this case is the LED here, L, is used, which is an internal LED connected to pin 11. Right, so we are using that particular LED in our example here. So let's transfer this code by clicking the upload button here. Now let's open the serial monitor. Right now the distance is around 8 inches. Right now let's move the obstacle close, and you see once the obstacle is closed less than 5 inches, in our case here this is 1.25 inches, right? So you can see the LED up here is blinking, right? So which is the LED connected to pin number 13, right? So now as I move the obstacle far away, and as the distance grows more than 5 inches, you see that LED is no more blinking. So thank you for watching this video. I hope you enjoyed this video, and I will see you in next video.